take a look at a Leetcode problem called permutation in string. So we're given S1, S2, write a function to return true if S2 contains the permutation of S1. In the other word, one of the first strings permutation is the substring of the second string. So I find this question to be very, very similar to Leetcode 76, which is called minimum window substring. So I find that if you can be able to solve that problem, this is kind of like a similar type. So the idea is pretty simple. We want to see if S2 contains a permutation of S1, right? So in this case, we have BA, which is a permutation of AB. And in this case, that won't work because we need to have those letters right next to each other, right? In this case, we must have AB or BA, right? We cannot have BOA, so that won't work. So we need to make sure we have a window, right? At the end, we're going to have a window that has a size that's equal to S1 that size, right? What we're going to do is we're going to first, just like how we did it in the minimum window substring, we're just going to first expand our window, right? In this case, we're going to expand our window if we don't satisfy the condition. And if we satisfy the condition, we're going to start a contract our window. And every time we contract our window, we want to make sure we update the length, the current length of the string. And then basically the condition that we want to satisfy is that if we're basically trying to satisfy a condition, and the condition that we want to satisfy is check to see if the window, right, if our current window contains all the letters that contains in S1, right? Does our current window has all the letters that contains in S1? If it does, now let's start a contractor window, right? Every time we contract our window, we want to make sure to update our length of the window. And at the end, what we're going to do is we're going to see if the minimum window that we found, let's say 3, is it equal to the size of S1? If it is, then we're going to return true. Otherwise, we're going to return false, right? So I'm not going to go in diagram to show you how we do that. I pretty much show you how we're going to solve a similar problem for Leetcode 76. So I'm not going to show you that, but I'm just going to jump straight into code. If you want more detailed explanation, I have a video called Leetcode 76, minimum window substring. So be sure to check out that video. I feel like even though that question is that Leetcode problem is a hard question, but I find that question to be a lot easier for the permutation in string. If you get that question, you can get this question pretty well. So to do this in code, first we're going to define our table, right? Our table is there to basically define, is there to keep track if the current character that we added to our window is a character that contains in S1, right? If it is, then we want to make sure we decrement the appearance of in our table by 1. And if that's the case, then we're also going to increase the counter by 1. And we also need a counter, basically is there to keep track of how many characters we have added within our window that is contained from S1. Okay, so once we define our table, we're going to define the pointers, and the pointers is there to define where our window starts and where our window ends. And we're also going to basically fill up our table beforehand. So we're going to fill up our table with number of appearance of each character in S1. Then we're going to have a min length, or the min length. Define a min length, basically is there to keep track of the minimum length that we have seen that contains all the characters we have found in S1 within S2 for the window, right? We want to make sure we find the minimum length of our window that has all the characters in S1. At the end, we want to make sure we compare the minimum length with S1 if it's equal to each other. If it is, then we're going to equal to true, return true, otherwise return false, okay? And then we also going to, basically what we're going to do then is we're going to define our counter, okay? Our counter starts at 0, and then we're going to find or, basically check if there is a permutation, right? At the end, we're going to return if min length is equal to size of S1. Okay, so now let's try to fill them up. First, we're going to define our table, and our table is going to have a size of 128. And then that's pretty much how many characters we have in ASCII table, sorry. And then we're going to define our table pointers left and right, both start at the same position. And then we're going to fill up our table, right? So for each, so let's convert the string into a character array first. So let's say S1 array, right, is equal to S1.2 character array S2 array is going to equal to S2.2 character array. Okay, pretty simple. And now we're going to fill them up. For each character that we've seen in S1 array, we can say array at current. We're just going to increment that by 1 because we've seen that character. We're going to increase the number of appearance by 1 for that character. And then we can define the minimum length. So minimum length initially is going to be integer.max value because we want to make sure we set it to a very large value so that when we find a size, when we find a window, we want to make sure we update the minimum window. Then we're going to define our counter, which is 0. We haven't found any characters from our window that contains S1 yet. So now we're going to say while right pointer is less than S2 array dot length. First, we're going to expand our window, right? Then we're going to focus on contract our window or shrink our window. Okay. Then first, we're going to expand our window, and to expand our window, we're just going to add the current element. I should say decrement the element appearance by 1. So in this case, if let's get the current character. So current character, current, right, is equal to S2 array at R, which is the current element. If we decrement, right, array at current by 1, and it's still bigger than or equal to 0, that means we know that this character contains in S1. So we're just going to increase the counter by 1. Okay, then what we're going to do is we're going to contract our window now. So what we're going to do is we say that if we found counter is equal to S1.length, then we're going to focus on, or I should say, yeah, counter, because this is a string, so we're going to make sure we say dot length, call it as a method. Okay, so if it's equal to the size of S1, we're going to make sure we update our minimum length, right? So in this case, current length is equal to right minus left plus 1, right? And then what we're going to do is if the current, we're going to update the minimum length. So minimum length is basically the minimum between current length and the minimum length, right? Once we update our minimum length, what we're going to do is we're going to make sure we update our counter as well. So we're going to increment, so array, let's do it. So character, so left character is equal to S2 at array at left. Okay, so that's our left character. We're going to say if we increase, because now we want to move our left pointer away from that character, so we want to make sure we increase the appearance, right? We want to restore that, so now it's going to be left char. We increase that number's appearance. If it's bigger than 0, right? If it's bigger than 0, means that we go from 0 to 1, or we basically means that we found a character that was from S1. Then we're just gonna decrement the counter by 1, right? Because we pretty much lose a character, right? We pretty much lose a character out of our window, so we want to make sure we decrement the character by decrement the counter by 1, and then we want to make sure we move the left pointer 1 to the right now, right? So pretty much we have 2 steps in our while loop, right? We update our minimum length, and we want to make sure we shrink our window. Then what we're going to do is we want to make sure we move the right pointer 1 to the right. Okay, so at the end, pretty simple now. We're going to return if minimum length at the end is equal to the size of s1.length. Okay. So now let's try to run our code. And let's try with a few more examples. So let's try to change this to O here, and this is A. Okay. And then now let's try to submit. And here to see, this is how we solve this permutation in string problem using sliding window. And the time complexity in this case is going to be linear. So there you have it, and thank you for watching.